Alright, and here we go. Sorry, just getting it all lined up. So, tonight, for electronicsy fun, I thought we would talk about this thing. In fact, we're going to do, I know I said I wasn't going to do teardowns, but we're going to take this apart. This is not actually Tetris. Well, it's kind of Tetris. Basically, I've got this plug and play thing that you plug into your TV and you can play Tetris on it. And this isn't it. In fact, the thing that it looks very similar to this, but this is in fact the secondary controller for it. So this plugs into the actual one, which looks just the same as this, and then you can play two-player Tetris at the same time. And this is actually the only plug and play thing I've got that has this particular, an extra controller. Except I've got oh, that's not true. I've got the that one where Who Wants to Be a Millionaire, that's got some extra controllers. But anyway, the point about this, the thing that interests me, and I'm just kind of curious about how it works, is that this is how it plugs in, and all it's got is this sort of headphone jack, headphone plug thing. It's actually a smaller version. It's a 2.5mm plug. And it's only got 3 little bits on it, so there's 1, 2, 3, but this transmits the information to the main unit, and then you can go left and right, and you can go up and down, so it moves around, and you can rotate the piece. So if you want to rotate your Tetris piece, you turn that way or that way, and then you can go up and down, though it doesn't actually have up marks, so maybe you can't really go up, can you? Well, that's how you turn. Oh no, you turn like that. So you don't need to go up, do you? You just go down and left and right. So there's 5 different actions there, but there's only a wire with 3 things on it. So how does it work? And there's quite a few different ways that this could work, I guess. So there's different protocols, but there's only 3 things though. So it seems strange. I don't know what it might be, but the way that I thought about it, one of the screws has fallen out. So I've kind of cheated a bit and loosened the screws so that the taking apart part won't take too long. The taking apart part, that was quite funny. But before I do that, so my idea is maybe it does this trick where, because we've just talked about resistors and voltages and resistor dividers, voltage dividers with resistors, you can do a trick where you can have a button and you can have multiple buttons, and basically you can read which button you've pressed by testing the voltage. That'd be better to explain it with this way. So what you basically do is you set up, so if you're doing it with a microcontroller, and you have your little Arduino thing, and I don't have one sitting on the desk in front of me, but they're around, they have analog inputs, and you could use one little input to actually test for multiple buttons. And I know that there's a little plug-in shield thing that you can get, that has like a little LCD display and it has like a bunch of little buttons in it that uses this technique. So it kind of works. I don't know how off the top of my head exactly how it works because I never made one myself. I've just used the one that's on that little shield thing. But the idea is that, so here's your voltage that you supply a positive voltage here, and there's a 0 voltage over here. And you have some resistor. So in here I put 100 ohms. It doesn't have to be, that's not a set value. That's just the value I'm using for the example. And then you have this thing where the circuit breaks off. It's a parallel circuit for each button that you have. And each button, so this is a button symbol, will make a connection. So if I press this button, then you'll have a connection that goes through here, so you've got your voltage drop over here, and you're going through 2 different resistors. So you see 2 resistors, and you should think voltage divider. And so here you've got a voltage divider with 100 ohms and 100 ohms. But if they press this button, you get a different voltage divider, and that'd be 100 ohms and 200 ohms. And here I put a little line in, and this is where you're going to test it. So this bit here would go off to, say, your analog input pin on your microcontroller, and you would test the voltage to see you would test what the voltage is at this point here, and depending on which button you press, you'll get a different voltage being recorded here. So just going through step by step how that might work, just to get through it sort of clarified. turn this around. You can actually kind of see everything through the paper. You can't have that. You have 2 pieces of paper, and then you can't cheat. Alright, so we'll do this step by step. So, alright. And so let's just do the first case. If you press the first button, this is essentially the circuit you get. And I'm going to use 5 volts here. So in this case, there's 5 volts here, and then we're going to, I can show you what the voltages are. So it's a voltage divider, 100 ohms here, 100 ohms here. So these resistors are the same. So basically the voltage is going to get split between the two. Hopefully it can still, I think it's getting out of focus. Stay in focus, camera. Oops. I'll move it to the center. Okay, here we go. So 100 ohms, 100 ohms. So it's going to split the 5 volts, and you're going to get 2.5 volts here, the 2.5 volt drop here. So it's dropping by 2.5 volts. So 5 volts. And so when you record it, this is the measurement point. Here you'll be measuring 2.5. So the difference between here and ground or 0 volts is 2.5, and that's what you're going to measure. Alright, so that's if you press the first button, button 1. And if you press the second button, you will get 100 ohms here and 200 ohms here, and then you're going to get them split. 2/3 of the voltage is going to go through this one because there's more work to be done here. It's twice as hard to get through here, and 1/3 of the voltage will go through here. So we end up having 3.3 volts going through here. So if you measure the voltage between here and ground or 0 volts, it's going to be 3.3 volts. So when you press button 2, you're going to read 3.3 volts. And the very last bit is, the question is, what happens if you press both the buttons at the same time? Well, in that case, you get this kind of circuit, where you go through, I didn't write in, that's 100 ohms, still hasn't changed, I forgot to write it in. But then you've got 100 ohms in this way, and you've got 200 ohms in this way, and I haven't gone through parallel circuits yet, but we'll just quickly do the math for it. Except I've got the pages in the wrong order, and there we go. So in this case here, this is the circuit that we're drawing. So R1, so this is a parallel circuit, and so this bit is general maths. So we'll just do, this is for a later date, but basically if you have one resistor and two resistors, so resistor 1, resistor 2, and they are in parallel, which means they're like this. So they go together, but they're linked at the end. So in this case here, they're linked at the end because they both go to 0 volts, so they're linking up to the 0 volt point. So this is what they look like. I'll put the page away. And to calculate the actual resistance over those two areas, between these 2 points, so what's the total resistance between here and here, or what's the effective resistance, not the total resistance, so what's the effective resistance for the rest of the circuit between these 2 points here? And to work this out, it's kind of a strange formula, but it's 1 over R, and that's R there, equals 1 over R1 plus 1 over R2. So I'm sorry if my R's don't look very good. So in the case of what we've got, R1 is 100 ohms and R2 is 200 ohms. So 1 over R, looking very messy here, 1 over R is 1 over 100 plus 1 over 200. A quick bit of maths, that equals 100 plus 200 over 100 times 200. I'm assuming for today everybody knows how to do that kind of thing. And the answer for that is, that's meant to be an arrow, not a smiley face or some bizarre symbol. So I'm saying that leads to this. So this equals 3 over 200. I'll let you do the maths if you're not too keen on, if you don't understand how I got from there to there. So 3 over 200. So therefore R, which is, so this is 1 over R is 3 over 200. So R is 200 over 3. So 200 over 3 ohms. So you're flipping it over. So that's the reciprocal. So you flip it over, you get 200 over 3, which is about 67 ohms. So 66.6 recurring ohms. So if we go back to here, the effective voltage of this section is 66.7, and alright, it's very exciting here. We've got lots of, hopefully this is, so if we plug those values in, 100 ohms still over this part of the circuit, but now the effective part of the second part of the circuit is 67 ohms, and this roughly comes up to 3 volts going across the first resistor and 2 volts going across the thing. So if we were to measure at this point here, we'll get 2 volts. And so I summarize this. I'm going to leave the bottom part off. If button 1 is on or pressed, and button 2 is off or not pressed, then you're going to read at your checking point 2.5 volts. So there. And if the first button is off but the second button is on, you're going to read 3.3 volts. And if both of them are on, you're going to read 2 volts. So you've managed to be able to read the state of all 2 buttons, even if they're both on, just by reading one analog input. And the last bit is what happens if they're not actually pressed on. Well, you'd probably have something I didn't draw in the circuit. I'm going to guess you'd probably have another one coming off here. So there'd be another thing, another resistor that would be something like, sorry, I have to turn it over, I don't know, some huge value, 1 million ohms, right? So when you get 1 million ohms, so basically when you have anything in parallel, the actual total resistance is always going to be, or the effective resistance across a parallel thing is always less than any particular resistance in any branch. And that makes sense if you think about it, because if I can go this way and get 100 ohms, then I have to, and if the answer happened to be that the effective resistance of both paths was higher, that wouldn't make any sense, because I could just send everything down this one here and not down the other one. So basically it always has to be less than either of these two values, because you're getting this value, you're getting this path, and you're getting another path, and so you're split. So your little boxes are going to come through here, and they can go 2 different ways. And this way is just as easy as it. Yeah, I don't know if I explained that, but the point is it has to be lower than that. So the thing here is, if this is 1 million, and if you test it and you haven't pressed any buttons, then you're going to get a very high thing here and a very low here. So your voltage divider is going to end up saying something close to 5 volts. When you test it at this point here, it's going to be something close to 5 volts. But as soon as you press any of these buttons, they're vastly easier route to go. So this 1 million ohms is hardly going to affect what you read. So it's not going to change the values much. And in fact, this is kind of how, like in a multimeter, that's what's happening. So the test probe has a very high resistance, so that it doesn't actually affect the operation of the rest of the circuit. But anyway, so the answer to what I would put at the bottom was that if they're both off, then I would put in a very large resistor on the side, and you'd get approximately 5 volts. So then you've been able to read all 4 states of 2 buttons without using more than 1 pin. So, and of course you can do this with multiple buttons. And so I put my white paper back. Seems to make it go. Maybe or not. We'll have it there. But sorry if it goes too yellow. But so here I was thinking maybe that's just what they did here. So you can have more than 1 button, and you can still just have the 1 pin. So one of these is, as a theory, one of these is the positive voltage, one of them is ground, and one of them is the sense pin that you're reading, which is the analog value from whatever voltage divider setup you've got in here to read each different direction. So the exact value, the numbers that you use are more intelligent than the ones I would use, so look it up online and find out how to do that in a better way. But there must be. Since that button, the controller on that little LCD thing has, like, I think 6 buttons or something, and that uses 1 pin. So this can, you've got like 5 different options here. So this should be enough. This should be a simple way of doing it. So is that what they've done on the inside, or have they done something more complicated? So to work this out, we'll take it apart and we'll see if there's just a bunch of resistors. I'm a bit worried that if I take it apart, I won't get it back together again. Because this is not one of those channels where someone takes things apart, puts them back together, and everyone seems very clever about it. This is a channel where I take things apart and I break them. especially when I'm using the wrong kind of screwdriver. Alright, so they're mostly undone, except for that one, which I can, oh, that's not even, alright. Yeah, it's the only Phillips screwdriver I could find at the time. Right. It's amazing how many screwdrivers I have, and as soon as I want one, I know I should have like a little thing. I'm gonna get to that point where I have like lots of little, come on, this all fall out. Okay, they all fell out. So far it's looking quite simple. So I mean, I would think like if you had any other sort of system, you would have to have some kind of microcontroller or something to translate encode it all and send it down in some sort of fancy way. So this is actually going to lead on. So I'm quite keen on like joysticks and joypad controllers for old computers, and in particular, so I watched the 8-bit guy, he has a really good channel, and he did a video recently about how old school game controllers worked. So I've got lots of old school game controllers. So we're going to do a couple of videos about that, and including one of making, so the next sort of project, which is a very simple project, which is a joystick tester for old school Atari style joysticks. But we're going to lead on, this is what you get, this is the worst screwdriver to use for this. Surely I have a better one. What's this one? This is the one with a funny handle. The wiggly handle. Alright, so we'll take this off. Oh my goodness, come on. This is just an electric screwdriver like fancy people have. I'm not going to actually go through putting this back together on the camera, so you don't have to worry about that. There's a bit of plastic, there's a spring. It doesn't seem like it's going to be too hard to put back together. So if we look in here, and I can't really, I don't know if I can get you guys to see this, but we can take the buttons off. So actually, so when that moves, how does this actually work? Oh, there's a few more wires going into there. So I don't know if I can get that. Oh, I have to take the screws out. So something is going on behind here. So when you do turn it, it does do something. But there are only 3 buttons on here. So we can take this rubber stuff off without breaking it. Oh, I see what you've got to do. So right, that spring. I'm worried the spring's going to fall out. It fell out. Okay. If you look on here, I can basically see there's 1, 2, 3, 4. There's nothing but resistors on here, and so they all seem to be leading that way. So I can't, of course, read the value. I don't have a magnifying glass. That's going to be good enough. I'm going to use my little helping handstand thing. One of them says, I think it says 822, which I assume means 800. 8,200, and what else have we got? We've got 333, so that's 33,000, so that's a lot higher. And what else have we got? There's another 822 or 153, 333. Maybe they don't. Well, that seems like the only possible way that this could work. That's all there are. There's only, so there's, wait, 1, 2, 3, 4, 5. There's 5 resistors, which is what you would think, what you would expect, right? Because there are 5 different options. So hold on, let's just check these out. So one is 153, one is 333, one is 822, one is 153 again. Oh no, there's actually 6. 228. 822 again, and 333. So, well, they must work that way. I don't know. I'm guessing they work this way. So what we're going to do, what we need to do, I'm going to take it apart right this second. We are going to, it's pretty obvious, so the blue wire is the ground one. Where did I put my multimeter? Alright, so yeah, as I was saying, we've got 9 more minutes. I'm going to have to upgrade my internet. So I'm going to do this, and we're going to test. So I'm pretty sure that these two here are attached to the ground. So the blue wire, is that right? Why would they have two different blues going to this one? So I'm going to guess that the white one is the +5. So let's just see. It's the positive voltage, not +5. The blue one is the ground. And the red one is the output. So let's just take this thing and find out which part of this thing ground attaches to. I don't know if I'm going to do this with my hands. Alright. So it should go beep. Alright. So the top part of the thing is ground, I believe. And then this one here is going to be the top. So this one's the positive voltage. And let's just guess it's going to be the top thing. No. So that's ground, the middle part's the voltage in, and then the output is going to be on the top pin. So I could actually just test it. Of course, maybe it's just testing the resistance. Maybe you don't need to have. So what do they have two things for? Who knows? I guess you only need 2 pins to do it that way, don't you? So then you don't need all 3. I don't know. Let's just test the resistance. So I'm going to test the resistance over here between the ground pin. I'm going to put this on. I don't know if you can see it. Probably can't. You can see it fine. Alright, so if I put, I really should have changed the things over to the clippy ones. Alright, and then I put this on the red, and then I touch one of the buttons. This is going to be hard. No, I need the little rubber thing. Where'd the rubber thing go? I've actually lost the rubber thing. Oh, there it is. Okay, we will have to put this. How much time have we got? 6 minutes. We will have to put this back on for this test to work. And the spring goes in the middle. And that goes in there. It doesn't look anywhere near as good as it did a minute ago. Whoops. Oh, we're missing something, aren't we? This plastic bit. Okay, thank goodness I filmed it, because then I'm going to have to go back and find out what on earth I just did. Alright, so hopefully, I think they actually go in different holes. Alright, so there's a confusing number of little holes they could possibly go into. They seem to want to go into those. Alright, so let's do this. Stop rambling. That one goes there. That one goes there. This is not working at all. Alright, actually, what did I set it to? 2000. Well, let's just stick it really high. Maybe I got this totally wrong and this was a waste of time. Maybe I'm not actually pressing the button. Oh, there we go. So what are we getting there? Oh, it's actually quite low, isn't it? Okay, go back down to there. Maybe that's oh, okay, I know what that is. Okay, right. That didn't work. Nope, nope, nope. Nope, 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 nope. Okay, I'm going to give up in a second because this is going to get too boring. Guess I just have to take it apart. We can just quickly look at this. No, we can't. That goes through there. That one goes to there. It looks more complicated than what I've got, but that's okay. Right, you can probably do it with far less. I don't know. Putting that back there. So I think we'll just end it there because there isn't much else to say, and I will try and put that back together. I'll put it back together, and then I'll just measure it straight off this plug here and see what happens. So once it's all back to working the way it used to work, I'll get out the little leads that clip onto these things, and then hopefully we can test it better than we are currently doing, and see how it goes. Alright, sound good? Cool, thanks. I hope that was kind of interesting or informative. Or not. Cool. Thank you. Have a good evening. Bye bye. And blah blah blah.